natural disasters bring out the best and the worst in us as a people. The best in terms of showcasing the bilingual culture, camaraderie, and having a helping hand to those in need in terms of rescue and relief. In fairness, we've become very good at this as a nation. Thanks very much to institutions and private individuals for augmenting what the government can provide. As a scientist, however, I also see the worst coming out during these natural calamities. Just think of it. I see people surrendering to the forces of nature and accepting that this is just part of their fate. It is being part of Filipino. Wading in the floods of Ondoy is just as Filipino as adobo or charis bento. The mindset that it is part of our culture is that there is no learning involved every time a calamity hits us. We always start from the very beginning. If we consider natural calamities as a sporting activity, dodging these disasters as a sporting activity, we cannot claim that we lack practices. In fact, we should have been very good, if it were a sporting activity. Every 12 or 13 years, we get a major drought in the Philippines. The last was last summer. Prior to this was in 1997, and before 1997 there was one in 1984. Every 5 years there's a volcano somewhere in the archipelago erupting. And every year we are visited, and of course we welcome them in open arms, about 12 typhoons. And these typhoons cause landslides and massive flood. And let's just focus on one thing, that property damage, and just focus on flooding causing damage to property. This, of course, is caused by strong rains, which we can't do anything. Strong rains cause an anomalous amount of water flow into our rivers, and which cause property damage. In truth, damage to property is a bigger problem, and there are compounding factors other than just having strong rains. No warning system, poor zoning, ignorance of the hazards, poor construction of your houses, and so on and so forth. And therefore, if you want to solve the central problem of decreasing property damage due to natural hazards, we may have to go through any of these envelopes of other problems. The problem, however, with these problems is that it's actually more complicated, because before you get to the central problem, there are other problems that we have to deal with. A few weeks ago, I was talking to a sociologist friend of mine, and I was discussing with him my idea of this problem, a web of problems, and I said, how can you solve a problem that is quite complex, like the link between property damage and corruption? It just goes on a loop. One problem causes another problem, the second problem gives birth to another problem, and this third problem is actually connected to the first problem. How do you solve this problem? And I said, maybe in this complex web of problems, there are simpler links of problems wherein they are not compounding reasons for their existence. And I isolate two chains for this problem. One, because of strong rains. The other reason, because there is no warning system in the Philippines. These two problems are caused by two other problems, no forecasting, and the other one, strong rains, because rains come from the heavens, and I'm assuming that God is in control of the faucet in the heavens, and it is God's fault. Okay? So between these two problems, I was thinking, what is the easier problem to solve? Like you already know that I chose to talk to God. Actually, I'm sure God is easy to talk to. He's probably a nice guy, or a girl, man, but I chose forecasting. This is something that we lack in the Philippines. Forecasting the weather in the Philippines may be a monumental task. No one has done this week. But I assembled a team of scientists and engineers in UP to directly address this particular problem. And this is the essence of a DOST-funded project which started just this month, which we nicknamed the Climate X Project. And the premise of this project is that we actually can predict the weather this afternoon, tomorrow, and even the day after. This is the very foundation of this project. Because of the lack of time, I cannot discuss all the details, but just to share with you some ideas that will be coming into this project. It turns out that satellite imagery is available in the internet for free. And there are at least 20 sites wherein you can download meteorological data for free. The problem is that these sites only show you the last satellite image, and you cannot access the archive data. You need archive data in order for you to compute for the path of typhoons and so on and so forth. So I assembled a group of friends from engineering, and we actually formed a small company called GS Metrics. And one of our products was a hacking software. And this software, I know that there's some copyright issue here, but we'll deal with that later. This software here, when installed in your PC, just downloads, just gets all the information, all the images from different sites automatically, even at night. So it runs 24/7, and it downloads for you all satellite imagery. And what you have after 1 year is a massive database of meteorological data. This is the foundation of our forecasting that will happen very soon. This is one example of a satellite image that we download. And if you play it in sequence, and this is updated every hour, you actually see what you see on TV in Pag-asa, for example. And mind you, again, this is for free. Just don't tell whoever owns this site that we download it automatically, but this information is very important in terms of predicting how much rain you will get and where this rain will be falling. Just a short note, we forecast typhoons in the Philippines, and we become very good at this. Siguro sumasablay paminsan-minsan or medyo madalas, but my point here is that did you know that most of our rain, more than 50% of our rain, actually comes from other weather disturbances other than typhoons? And we don't do any forecasting in terms of monsoon rains, thunderstorms, ITCZ, cold front, and so on and so forth. This comprises 55% of all the rain we get per year. And so in our project, we also need to forecast these smaller events. How do we do it? Here's a satellite image of the Philippines on August 4. There were no typhoons, but it was raining very bad in the whole country. And I isolated some of the rain clouds, low pressure areas in the Philippines, like this. And the next step is actually to tag each one, tag each rain cloud, and give them a value of potential rainfall. And this value here can be taken from satellite imagery, as you saw in the picture, color-coded, or it can be taken as actual ground data from automated weather stations that Pag-asa owns. The next step then is to be able to track these distinct rain clouds, of where they're going, how fast they're going, and this will be the foundation of our forecasting afterwards. We will do away with the usual forecasting of sunny with scattered rain showers and thunderstorms, because this is the forecast for the whole year everywhere in the Philippines. It doesn't help us in any way. What we are proposing for Pag-asa is a forecasting that is useful in terms of percent chance of rain, in terms of how much rain we will get, and therefore people can plan ahead in terms of weather. The ultimate goal of the project is to be able to have weather data or weather information as ubiquitous as showbiz or politics news. And you get text messages that there will be a rain event happening 1 hour from now here in UP Diliman. This is the ultimate goal. It is a monumental task, but the team is up for the challenge. The team is composed again of UP scientists and engineers together with scientists in Pag-asa and asking UST. There needs to be some change in terms of how we do it, in terms of how we solve natural disasters. Something is being done, I assure you, and it is actually being done here in Diliman. Thank you very much.